Hey, sixth graders. Today we are going to think about trapezoids. So the unique thing about a trapezoid is that its top, or base one, is shorter, here's base one, than its bottom, which we will refer to as base two. So we're going to think about that in terms of someone's garden. So read along with me here. Lizette is building a garden in the shape of a trapezoid. The garden is 6 feet wide in the back and 10 feet wide in the front and 5 feet wide from back to front. She wants to find the area of the garden. All right, so if I labeled this 6 feet wide in the back, 10 feet wide in the front, and 5 feet from front to back. That would be the height of the trapezoid, right? 5 feet. We'll fill in these blanks. The shorter base, base one, represents the garden width of 6 feet. And the longer base, base two, represents the garden width of 10 feet. The height, h, represents the garden dimension of 5 feet. All right, useful information. What do we do with it? Well, we're going to model it first, and they're asking us to cut out a trapezoid like this and then double it. So I got started down here. Whoa, 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 I'm getting dizzy. I'm gonna zoom out here. So here's my first trapezoid here. Zoom out a little bit more. So I'm gonna lasso this one, flip it around. Oh, it was already flipped. There we go. I'll line that up there. Ah, stay put, you. Oh, it just really doesn't want to go there. Hang on. One more try. Let's do this first. I'm going to slide it in. Make it just a tiny bit bigger. Oh, what shape have we here? It's not perfectly formed, but what is that? So we have a parallelogram. Parallelogram. When we put two trapezoids together, I'm getting the impression that this is going to be a lot like when we doubled the triangle and it made a rectangle or a parallelogram. So then we could find the area of the parallelogram and half it. Let's take a look at what's going on up here. So it says, find the area of the parallelogram, then divide by 2. There you go. So what is our base? So our base is really a base 2 and a base 1 put together. So that's 6 plus 10. So 16. And our height, well, that didn't change. So that's still 5. 16 times 5. 5 times 6 is 30. 5 times 1 is 5 plus 3 is 8. So we've got 80 there, but that's for 2. That's the area of 2 trapezoids. So we need to divide 80 by 2. 8 divided by 2 is 4, 40. So the garden is 40 square feet. All right. So what figure is formed by the 2 trapezoids in activity 1? A parallelogram. Parallelogram. Isn't it nice that this big old word sounds out so well? Write an addition expression to represent the length of the base of the entire figure. So remember that was a base 1 plus a base 2. Oh, I guess maybe that is the addition expression. I'll just write that here. Base 1 plus base 2. Write a formula for the area of the parallelogram using base 1 plus base 2 and an h for height. Oh, yeah, okay. So the height times base 1 plus base 2. Okay, because the area of a parallelogram is, yeah, okay, that works. How does the area of each trapezoid compare to the area of the parallelogram? Well, each trapezoid was half, right? Was half the parallelogram. Each trapezoid, trapezoid, is half of the parallelogram. Write a formula for the area of each trapezoid using base 1 plus base 2. So half, so this whole thing up here, height, oh, that's a B, height times base 1 plus base 2, that's the area of the parallelogram, divided by 2. Would that work? Yeah, I think it would. Or we could write it as half times the height. Hang on a second here. Half times the height times base 1 plus base 2. There we go. I needed a different bracket than the parentheses so it wouldn't get confusing. There is another way to find the area of a trapezoid. And this picture right here really helps you to see it. When you draw in the height on both sides like that, you can clearly see that you actually have a rectangle and two triangles. Oh, so could we find the rectangle? The area of the rectangle is length times width, 5 times 6, which is 30. And then the area of the triangles, the area of each triangle is, oh, I see what that X is. Okay, so it's 3 times 5, right? 3 times 5, and we would need to divide that by 2. So 15 divided by 2, half of 14 is 7, so half of 15 is 7.5. I don't know why they divided that by 2, because these two triangles are clearly congruent. We could have just done 3 times 5, because this rectangle plus this triangle plus this triangle is one rectangle, right? But they did that. Okay, so 7.5. So we have 30 plus 7.5 plus 7.5. So that's 30 plus 15, 30, 45. 45 square inches. Cool. So there's two ways. You could double it like it's a parallelogram, or you could find the area of the rectangle and the two triangles. Whichever you're more comfortable with, really. What do you see? What works for you? All right, go try some on your own. You can work with a partner if you wish. You can also come ask me for help if I'm not working with the other grade level. Have a good time.